Okay, here we go. Next problem. It says find the value of each variable in the given parallelogram. And so y plus 8, you got y plus 8 up here on the top. It's going to equal, since opposite sides of a parallelogram are the same, it's going to equal 5y. Everybody good with that? We solve it. Help me solve it, Riley. Take my y, move it over here. How many y's do I now have? 6. Careful. Plus becomes... So 4y is 8, and y must be good. And you can plug that in, you would get 10, and you get 10. The two angles. These are not opposite angles, these are consecutive angles. Matt, or you can think of it like that. These two red lines are parallel. These are same side interior angles. So Matt, finish this equation for me. 4x. Does it equal 2x minus 6? Plus 2x minus 6 equals same side interior angle. When two parallel lines are cut by transversal, same side interior angles are always supplemental. Adds up to 180. Remember that. In a parallelogram, another way to think about it, in a parallelogram, opposite sides are equal. Opposite angles are equal. Opposite angles are equal. Consecutive angles will always be supplementary. So there's your equation. Trace, help me solve it. How many x's do I have?
6.
Good. And Trace, take my minus 6 and move it over here. What's it equal to over there now? 1. Careful. Minus 6. There we go. And folks, when you divide this, don't use a calculator to divide this. Do you see the 18 and the 6? When you divide that by 6, you get 31. 3 and a 1. So x is 31 and y is 2. Always look for that. Still staying on the properties of parallelogram. Find the value of each variable. Here you have a parallelogram that's got both diagonals there. Remind me, Colton, when a parallelogram, you've got two diagonals, what are those diagonals are going to do? The diagonals of a parallelogram will always, does anybody remember? Or just tell me what this is. Not median, midpoint. The diagonals of a parallelogram bisect each other. They cut each other in half. So this and this is the same, this and this is the same, so there's your equation. 3z minus 4, which is the distance from here to here, will equal z plus 5. Move my z's to the left, move my numbers to the right, I get 2z's is 9, so z must be 4.5. Any questions? And you can plug that in, you're going to get 9.5 and 9.5 are your two. Determine the coordinates of the intersection of the diagonals. Determine the coordinates of the intersection of the diagonals. Think about what I just told you. Let's make this a little bit easier. Okay. The two diagonals, remind me once again, Dylan Coop. The two diagonals in a parallelogram do what to each other? Two diagonals of a parallelogram will always, y'all help them out.
Bisect.
Bisect, there we go. Diagonals bisect each other, so they're going to cross where? In the middle, at the midpoint. So if the diagonals are going to cross at the midpoint, can I not just find the midpoint of these two? Or I can find the midpoint of these two, and is that not where the diagonals are going to intersect? That's the easy way. So this is the point 3, 5, and we'll check it. This is the point -3, -4. Guys, hopefully by this point, you're pretty good at finding midpoints, right? Add your x's, divide by 2. Add your y's, divide by 2. Riley, do that for me. Add your x's. I'm going to put a big M next to it. Add your x's, divide by 2. What do you get? Riley?
0.
0. Add your y's, divide by 2, and you get?
-2.
Careful. You got 1. Divide that by 2, you get half. So the midpoint should be at 0, 1/2, which would be right there. Yep. It's nearly the origin. And we can check that by using the other two because both diagonals, if I drew this diagonal and I drew this diagonal, they should intersect at this midpoint and at this midpoint. So let's try it on the other one as well. I've got the point -2, 4, and I've got the point 2, -3. Add the x's divided by 2, you get 0. Add the y's divided by 2, you get 1/2. Same thing. So the two diagonals, if I drew this shape out, the diagonals would intersect at there. Okay. Oops. Let's see. Could I use slope to find midpoint? Definitely. To use slope to find midpoint, here's how you do it. Your slope here is, the rise is 9, because look, -4 up to 5. That's a rise of 9 and a run of 6. So if you want to find, where's the midpoint at? Instead of rising 9 and running 6, then rise 4.5 and run 3. But the only thing is rising 4.5 and running 3 from that. That's possible. That's possible. Now is that right? Rise. Yeah, run 3, because running 3 from here, that's right. Rise 4.5 from -4, that gives you 0.5, and then run 3, that makes you, from -3 to 3 would be 0. That's right. And that's another one just like it. We don't have to work another one of those. Let's do a proof. Yeah, we all love proofs. Like the excitement. You're given, look, you're given parallelogram ABDG. And now, as soon as you see that you're given a parallelogram, you know all these things are true. You know the opposite sides will be congruent. You know the opposite angles will be congruent. You know the consecutive angles will be supplementary. You know that, let's see, what else was it? Opposite sides and opposite sides are parallel and congruent. You have, if I had a diagonal, then I've got two congruent triangles. If I have two diagonals, then I have, they intersect at a midpoint, they bisect each other. I don't have all that. I have a parallelogram, and I also have that AL, which is this whole side, is congruent to FC. Before we go any further, take that parallelogram out of that shape, out of that triangle. That's isosceles. Okay, so statement number 1, ... we're given. I'm not going to list all that again. Statement number 2. Since, look what we're trying to prove. We're trying to prove, and I'm going to do this in blue. Here's what we're trying to prove. BDG, B to D to G, this angle, I'm trying to prove that that is congruent to angle C. That's weird. How are we going to do that? What do you know about angle A and angle C? This is actually a pretty easy proof. Okay, let's go with that. Angle A is congruent to angle C. Why? It's an isosceles triangle. And what kind of angles are those? No, not vertex, but base angles. Here's why. Base angles in an isosceles triangle are congruent. You're just telling me why. Tell me, if you're going to tell me something's true, just tell me why it's true. And you can't just say because it's an isosceles triangle, because if you told your mom, hey, Mom, it's because it's an isosceles triangle, she's going to say, and? So you got to elaborate on that. So now your next statement. If A, okay, we just said that A and C are congruent. Now look inside that parallelogram. What else is angle A equal to? Angle D. Perfect. Angle A and angle D are congruent. Because you've got a parallelogram there. And what kind of angles are those? In a parallelogram, I'm just going to put in a, let's call it a parallelogram. There we go. That's a good abbreviation, right? Parallel lines, parallelogram. In a parallelogram, these two angles would be your opposite. Opposite angles are congruent. Nearly done already, right? Ooh, I messed up major somewhere. Not angle D. You saw, and I made the same mistake there that a lot of times y'all are making. BDG. Thank you, angle BDG. The reason I can't say angle D is because angle D could be this angle, this angle, this angle, this angle, this angle, or the whole, we don't know. So we need to call it BDG. Plus it matches our proof now. So okay, now look what you got. Angle A is congruent to angle C. Angle A is also congruent to angle BDG. So, does that not mean that since both of these are the same thing as angle A, does that not mean that we know that now angle BDG is congruent to angle C? What property? Yes, thank you very much. Done that several times.
Yeah.
If two things are congruent to the same thing, that is the reflexive property of congruence. Good. Because we're dealing with congruent things. Actually a good proof. Now the next one, instead of going through the entire proof, let's just talk about how we would prove it, because I don't want to spend so much time on proofs. It says write a two-column proof for this. We're given that we have two parallelograms, and I want to prove, and let's do what we're trying to prove in a different color. I want to prove that HJ is congruent to ML. This is, again, fairly easy proof. What is HJ congruent to? Since that's a parallelogram up there, is HJ not congruent to PK? Okay, now is this not also a parallelogram? So PK is congruent to ML. So now are these two congruent? By? And we'll just use reflexive. They're congruent to, both of them are congruent to PK, so they're congruent to each other by transitive property congruence. Same thing on this one. Let's go through how we would prove it. Angle ABCD is a parallelogram, and we're given that angle A is a right angle. And I want to prove that they're all right angles. What's true about angle A and angle D? They're the same. They're congruent. So what you would do as far as proof goes, you'd say, okay, angle A is a right angle. Angle A measures 90 degrees, and since these are opposite angles in a parallelogram, it'll also measure 90 degrees, so it's also a right angle. What's true about A and C?
They're same size.
They are supplementary. Angle A and angle C are supplementary because they're same side interior angles, and since they're supplementary, the measure of angle A is 90, so what's the measure of angle C? 90, so it is also a right angle. Well, what about C and B? They're both opposite angles, so are they not also congruent? Measure of angle C is 90 degrees, so therefore the measure of angle B is 90 degrees. So are angles B, C, and D also right angles? Yeah. And you see, that's kind of common sense, right? A lot of these proofs that you're doing, it's just, the trouble is organizing it, right? But what you just did right there, that's what I want you to learn. I want you to learn to think through. How do I know that's true? The organization skills, yeah, that'll come, but I really want you to be able to think through this. And the last one, then we'll go on to something different. You have two parallelograms. Angle A is, here's what we're trying to prove, actually. We're given two parallelograms, and I'm going to do it in blue. We want to prove that angle A and angle F are congruent. Okay, what's the method? Here we go. Carly, since ABCH is a parallelogram, angle A will be congruent to what? Say again. I think you said. Since this is a parallelogram, angle A will be congruent to angle what? This one over here? Well, no, we're dealing with this parallelogram. B up here? What's the relationship, guys? Help her out. What's the relationship between A and B? Supplementary. They're same side interior angles. Guys, you gotta watch real close. Five properties of parallelograms. Opposite angles are congruent. That's what I was going for. BCH. These angles will be congruent. These two angles, which are called consecutive angles, will be supplementary. The opposite sides are always the same. The opposite sides are also parallel. And diagonals, we're not dealing with diagonals here, but diagonals bisect each other, and diagonals, one diagonal would also cut it into two congruent triangles. Now, Jagger, angle BCH, look at that there. I've got one tick mark there. What other angle in that other parallelogram on the other side, what angle will BCH be congruent to? DFG. How do we know that? Not quite yet. There's another step in between there. BCH What do you think, Hunter?
DCG.
It's congruent to DCG because that makes sense now, they're vertical. Now, with what Jagger said, now that we know that this is congruent to this is congruent to this, and do we know that this is also congruent to this? Is DCG, isn't that opposite angles with DFG here in that parallelogram? So do you see this is actually a really long reflexive property now? Since this is congruent to this angle is congruent to this angle, and this angle is congruent to this angle, then that means that angle A is congruent to angle L by the reflexive property. Okay, next up. What we just finished discussing is if you have a parallelogram, then all of this stuff is true. You've got these five five qualities that are true. And hopefully we drilled that in your head enough because we went over and over. Now we're going to be talking about conditions for parallelograms.
Miss Janet, come to the office, please.
Think back to when we did parallel lines. It's very similar. We started out with, okay, if two lines are parallel and they're cut by a transversal, then I know alternate interior angles are congruent. I know corresponding angles are congruent. I know same side interior angles are supplementary. I know same side exterior. We went over all that. And then the very next thing we did was, okay, how do I prove that two lines are parallel? Well, you prove that alternate interior angles are congruent. You prove that corresponding angles are congruent. So we went over, if they are parallel, then this is true. Then we went over is what needs to be true in order for it to be parallel. We're doing the same thing here. We just went over if it is a parallelogram, then this is true. Now, conditions for parallelogram is what needs to be true in order for it to be a parallelogram. Y'all see the difference? Here are your conditions. Need to put this in a separate column. So somewhere in your notes you have, if it's a parallelogram, that all this stuff is true. Now we're going to talk about what needs to be true. How can we prove that something is a parallelogram? And once we prove it's a parallelogram, then all that stuff that we already know, all that stuff is true. The first way to prove that something is a parallelogram. If it is a quadrilateral and both pairs of opposite sides are congruent. So if both pairs, you don't have to put that about a quadrilateral because obviously if it has five sides, it's probably in a parallelogram. So you got this quadrilateral, and the first way to prove it is both pairs of opposite sides are congruent. Right there. AD is congruent to BC, and AB is congruent to DC. It's a parallelogram. The second way to prove it, if both pairs of angles, opposite angles are congruent. If these are congruent and these are congruent, it's a parallelogram. The third way to prove it, if the diagonals bisect each other. BD cuts AC in half. AC cuts BD in half. They have to bisect each other. Not just one bisects one, but they have to bisect each other. And this last one down here says, if one pair of opposite sides are congruent and parallel. That means that the top and bottom here, not only are they congruent, but they're also parallel, then you have a parallelogram. Something else to throw in on top of all that. Go back to the definition of a parallelogram. Another way that you could actually, it's not, I wouldn't really call it proving it's a parallelogram, but if you got a four-sided shape and opposite sides are parallel, is that a parallelogram? Yeah. But that's by definition. That's not one of the conditions we're going to list. But if you know opposite sides are parallel, well, that's what a parallelogram is. Okay, so if you're given that, yeah, we know it's a parallelogram. So that's your conditions for parallelogram. If you want to prove, let me go back to that. If you want to prove that something is a parallelogram, well, you could use the definition and prove opposite sides are parallel. Or you can prove that opposite sides are congruent. Or you can prove that opposite angles are congruent. Or you can prove diagonals bisect each other, or you can prove that one side is both congruent and parallel. There's your conditions for a parallelogram. Here we're not going to go through this proof, but we're not going to actually do it, but we're going to look at this paragraph proof just to where you get another example of a paragraph proof. We've done a lot of two-column proofs, but not many parallel or paragraph proofs. It says, given that Wx and Zy is congruent. Wx and Zy is congruent. Given that these two are also congruent, we want to prove that that's a parallelogram. Look how they do this, and this is pretty interesting. What's in red was given. Are those two triangles congruent, by the way? For two different reasons.
Yes.
If we drew that diagonal, don't we have a theorem from that last section that stated a diagonal will always divide it into two congruent triangles? Well, that's very easy to prove. Isn't that diagonal equal to itself?
Yeah.
Those two triangles are congruent by side, side, side. So it says 2 points determine a line, so we can draw an auxiliary line from Z to X. So that you've now got two triangles. We're given that these are true. Also, we know that Zx is equal to itself by reflexive property, so we know that those two triangles are congruent by side, side, side. We've already discussed all that. By CPCTC, y'all remember that? CPCTC says once you determine that you have two congruent triangles, everything about them, all their corresponding parts will also be congruent. So let's write us a little congruent statement here because I want to know what corresponds. WXZ is congruent to, let's see, that's here to here to here. That's line 1 to line 3. So that would be Y to Z to X, right? So look at this. Since that's true, does angle WXZ, is it congruent to XZY? WXZ, XZY, yeah, or YZX, they're congruent. Right. And that's where they're going to head with this. WXZ, YZX are going to be congruent. And not only that, but WX or WZX, which is this angle, is going to be congruent to this angle. Do y'all see the Z's there? Yeah, focus for me, guys. Look at this Z. See that Z? What kind of, the one tick mark angles, what kind of angles are those? So are these lines parallel?
Yes.
Sure. Look at this Z. You see this Z?
Yes.
For the same reason you've got alternate interior angles, these two lines are also parallel. So by definition of a parallelogram, is that a parallelogram? Sure.
Yes.
Opposite sides are parallel, so by definition, WXYZ is parallel. So that's a proof. That's a paragraph proof of if opposite sides are equal, you have a parallelogram. Determine whether this is a parallelogram. Now this will be the last one we do for the day. I want to know, well, weird. I want to know, is this a parallelogram? How many different methods do you have to prove it's parallelogram? Besides definition, there are 4. We can prove that opposite sides are congruent. We can prove that opposite angles are congruent. That would prove it. What was the third method? Diagonals must bisect each other, or one set of opposite sides are both parallel and congruent. What about that?
The same side. And that the opposite angles.
80 and 100. Well, we don't know if it's a parallelogram though. Do y'all see where we're headed with that? He had a good theory. Well, if that's 100, then this is 100. Well, wait. Not necessarily, because that might not be a parallelogram. Because look at this. Here's you an extreme case. I know that this is not drawn to scale, but what if this is 100 and this is 80? Does that mean that this is 100? No, because this is not a parallelogram, correct? So we don't know yet if this is a parallelogram. Question though. Alex, are the tops parallel, top and bottom parallel? Is this line parallel to this line? Look at the angles. Focus on angles. What's true about those two angles? They're supplementary. So is this parallel? Yeah. And what was your fourth way to prove that this was a parallelogram?
Both pairs of opposite sides.
Or one pair of opposite sides is not only congruent but also parallel. Is that a parallelogram? Yes. And now, everybody listen to this. Do you remember how CP/CTC worked? Once you determine that two triangles was congruent, then you can say, okay, everything about them is congruent. Do you see how that kind of is similar to what I can do now? He made the statement a while ago, well, if this is 100, then this is 100. And I said, no, because we don't know if it's a parallelogram. Now we know it's a parallelogram. So do we know everything about it? Sure. If that's 100, now that we know it's a parallelogram, we can state that's 100. We can state that's 80. We know this side length? No. You don't know either of the two side lengths, but you do know it is a parallelogram. You know they're parallel. You do know that. Good job. But there's no way you could find that out because think about it. Could you shrink it down? Could you take out a middle section and shrink this down? Sure. So you can't. There's no way to determine about the side lengths. Is this a parallelogram? Let's see if this one will actually move or something. Okay. Is this a parallelogram? There's 4 ways to prove. Opposite sides are not given to be parallel. So there's 4 other ways to determine it's a parallelogram. First way, both sets of opposite sides are congruent. Riley, is this congruent to this? Are these other 2 sides congruent? Did they give you that? Or is there any way we can figure that out? And there's no way. We don't know. So check that off your list. We can't use that one. Both pairs of opposite angles are congruent. Matt, this is 85 and 85. That's congruent, right? Matt, is there any way we can find that? And a lot of people are going to say, yeah. Since this is parallel, right, we can do 85 and supplementary, so that'd be 95. Is that right? Do you know those are parallel?
No.
If it were a parallelogram, would you know it's parallel? Yes. Do we know it's a parallelogram? That's what we're trying to prove. So, Matt, do I know that this is 95? No. Do I know this is 95? No. So, do we know that both pairs of opposite angles are congruent? No. So, check. We can't use either one of those. The third method, diagonals bisect each other. Can you use that? I'd say not. You don't have any lengths. You don't know if the diagonals are going to cut each other in half. And the last method, if opposite, now we're on the right track here. Opposite sides are congruent. One set of opposite sides is congruent and also parallel. Can you say those are parallel? No. So is that a parallelogram? We don't know. Could it be? If that's 95 degrees, yes, that's a parallelogram. But we don't know. Okay. Is that a parallelogram? Here's a tough one. Trace. What's the first method for determining if something's a parallelogram? What'd you write down there? Is that written down? Opposite. First one. Both pairs of opposite sides are congruent. Both sets of opposite sides. Are those congruent? Yep. Are those congruent? Yep. Is that a parallelogram? Yeah. And now that we know it's a parallelogram, this is parallel to this, this is parallel to this, this is congruent to this, this is congruent to this, this is supplementary to this. And if I say that enough, maybe it's just going to stick. Diagonals bisect each other. A single diagonal divides it into 2 congruent triangles. If one angle is a right angle, then all 4 is a right angle. Okay, moving on. The diagram shows a side view of a tackle box. PQ and RS. PQ and RS are congruent. PR and QS are congruent. Explain why the upper and middle trays remain parallel no matter what height. You ever thought about that? If you've got a tackle box, I would really hate to know that as I close my tackle box that these 2 don't remain parallel. Right? Because as you close it, if one of them doesn't remain parallel, it's going to dump every bit of your tackle into your box. That would be a bad thing. But as you open that, you ever thought about that? As you open your tackle box, they remain perfectly parallel. Mm-hmm. Why? PQRS is a parallelogram. And no matter what you do, it will always be, no matter how you change these angles, it'll always be a parallelogram. Why? Because opposite sides, both sets of opposite sides will always be equal lengths. So therefore, PQRS, no matter how you change that angle, now as you change it, this angle will always equal that angle. This angle will always equal this angle. But no matter how you change it, as you're closing that tackle box, not only is this a parallelogram, but if you want to get technical about it, that's also a parallelogram. Because opposite sides will always be congruent. Robotics, you deal with stuff like that in robotics for robotic arms. A lot of times if you want to use an extendable arm or something, you can do something like that. I'm going to skip that one. Let's work one or two. If FK is 3x minus 1, and KG is 4y plus 3, JK, just kidding, is 6y minus 2, and KH is 2x plus 3. Find the values of x and y that makes this a parallelogram. This is very similar to that whole parallel line things that we did. What makes that a parallelogram? Okay, 4 things can make it a parallelogram. Opposite sides are congruent, doesn't have to be. Opposite angles are congruent, doesn't have to be. Diagonals do what? So therefore, in order for this to be a parallelogram, K has to be a midpoint of both of them. So y'all help me, anybody. 3x minus 1 would have to, and not only that, but 6y minus 2 would. And let's solve that. Move the x to the left, move the numbers to the right, you get x's. Good. And move the y's to the left, numbers to the right, you get 2 y's is 5, so y is 2.5. And you can plug those back in just to check yourself. X is 4, which makes that 11. It makes that 11. Y is 2.5, which makes that 13, and makes that 13. But the diagonals aren't the same. Now I'm getting ahead of myself. I thought the diagonals had to be the same. Is that not what it says? It says the diagonals have to cut each other in half. You tell me what we're about to get into. What if those diagonals are the same? Is the parallelogram possible? Yeah, good chance. But not only is that, I don't know, if just because the diagonals are the same doesn't necessarily mean that it's a parallelogram. But what shape would it be? Shrink that, or make that 11 and 11 grow to where it's 13 and 13 too. You're close. A rectangle. If the diagonals are the same length, it'll always be a rectangle, and that's to come. We'll work that later on.